In August of 2012, the world celebrated a milestone that turned out to be wrong. A spacecraft called Voyager 1 crossed an invisible line, and every headline said the same thing. It had finally left the solar system, except that it had not, and it will not for a very long time. Because the true edge of our solar system was not behind Voyager, it was still thousands of times farther ahead. So far ahead that Voyager, racing outward at 38,000 miles an hour, will not reach the start of it for another 300 years. And it will not pass all the way through to the far side for nearly 30,000. That edge is the strangest part of our solar system, and you have never once seen it. It is called the Oort cloud, and no one has ever seen it with any telescope ever built. By the end of this video, you will understand two things about it that should genuinely unsettle you. It is the reason we may be trapped here forever, and something is already falling toward it that will one day reach through and touch us. Start with the picture of the solar system you carry from school, with the sun in the middle and the planets in neat rings. That tidy image is almost entirely wrong, not because anything in it is false, but because of everything it leaves out. If you drew that whole diagram to scale on a sheet of paper, you would have drawn about 1% of the real solar system. The outermost planet Neptune orbits at about 30 times the Earth-Sun distance, and that is the edge of the familiar neighborhood. The Oort cloud is in another category entirely, beginning around 2,000 times that distance and stretching out perhaps to 100,000. Shrink it down until the whole planetary system would fit on a dining table, and the Oort cloud would not begin until 1.5 miles away. The planets are a few specks of dust in the middle of a sphere, 1 mile wide. The Oort cloud is not a ring, and it is not a belt, it is a hollow shell of ice wrapping the sun from every direction at once. We are not living on a flat disk, we are living inside a bubble. Out in that shell drift trillions of frozen worlds, the pristine leftovers of the solar system's birth 4.5 billion years ago. It is tempting to imagine they formed out there and stayed quietly since the beginning, but the truth is far more violent. They were born much closer in, near the giant planets, and as Jupiter and Saturn shifted into their modern orbits, their gravity flung the leftover ice outward. Most of it stalled at the farthest edge of the sun's reach, in the cold and the dark, where it has waited ever since. The Oort cloud is not a peaceful nursery, it is a graveyard of construction debris the giant planets threw away 4 billion years ago. Those trillions of objects are spread so thin that the average distance between any two of them is tens of millions of miles. Imagine standing on the surface of one of these worlds, only a few miles across, its gravity barely registering against your boots. You could jump gently and stay aloft for minutes at a time before drifting slowly back down. The ground under you is not rock, but ice compacted by billions of years of cold into something harder than steel. Because out here, our star is no longer a sun at all, just the brightest point of light in an ordinary sky. No warmth, no sound, just you and the ice, and an orbit so slow that one lap takes longer than all of human civilization. It is the loneliest, darkest, emptiest place that still just barely belongs to us. Which brings us to the most unsettling fact of all. We have never seen it, not the shell, not a single confirmed object inside it, not with any telescope ever built. Everything we believe about its size and shape and history, we believe without ever having laid eyes on it. So, how do we know it is even there? And the answer is that it has been sending us messages for as long as people have looked up. The messengers are comets. And in 1950, a Dutch astronomer named Jan Oort noticed something about them that should not have been possible. The comets that fall toward the sun do not arrive along the flat plane of the planets. They drop in from above, they climb up from below, they come at us from every angle imaginable. If they fell out of a flat ring, they would all arrive on roughly the same plane, like cars merging onto one highway. It cannot be a ring and it cannot be a disk, it has to be a sphere. And the comets carried a second clue, because every time one passes the sun, the heat boils away its ice into that glowing tail. The tail is the comet slowly bleeding to death, so no comet can last forever. Yet fresh ones keep arriving after 4.5 billion years, which means a hidden reservoir must be holding billions of them out there. We know the Oort cloud exists because without it, the comets we still see could not exist either. But that raises a darker question, because what reaches into that reservoir and knocks a comet loose toward the sun? Out at the edge of the Oort cloud, the sun's gravity has faded to a whisper, so weak it is no longer the only thing pulling on these worlds. The combined mass of the entire Milky Way can be felt out there, in what astronomers call the galactic tide. Just as the moon raises tides in our oceans, the galaxy raises tides in the Oort cloud, periodically shaking comets loose toward us. And then in 2025, this strange picture got stranger. For decades, astronomers assumed the denser inner region of the cloud was a smooth, simple disk. But David Nesvorný and his colleagues at the Southwest Research Institute ran simulations on a NASA supercomputer and found something nobody had predicted. The inner Oort cloud is not a smooth disk at all. It is warped into a spiral of two great twisting arms of ice. From a distance, the edge of our solar system would not look like a disk or a shell, it would look like a tiny galaxy. The galactic tide had slowly twisted these orbits into a spiral that echoes the shape of the very galaxy that sculpted it. And here is the detail that shows how blind we still are, because we did not photograph that spiral. We found a galaxy-shaped structure at the edge of our own solar system inside a computer simulation, because the real thing is completely invisible. For most of history, that was where the story ended, a shell we could deduce but never touch. And then the James Webb Space Telescope changed what was possible, because the same instrument built to read distant planets can read a chunk of ice in our own backyard. In late 2022, it turned toward an object that had no business doing what it was doing. Its name is Comet Bernardinelli-Bernstein, and when astronomers ran its orbit, the numbers came back wrong in a way that fit nothing anyone expected. The solid nucleus of this comet is roughly 85 miles across, while Halley's comet has a nucleus about 9 miles wide. If you set one end of it down in Lower Manhattan, the other end would reach Philadelphia, a single object falling in from the Oort cloud, the size of a small American state. And when Webb looked closer, more than 1 billion miles out, it caught the comet bleeding carbon dioxide off its nucleus. The models said nothing this big should have survived being flung out there in the first place. Yet here it was, and if one this large exists, it is almost certainly not alone. Webb did not just describe one comet, it described a whole population that was not supposed to exist. So here is everything we know about the edge of our home. It is a shell of trillions of frozen worlds, shaped like a sphere with a hidden spiral at its heart, held together by the grip of the entire galaxy. The Oort cloud is not a wall, it is a thin, permeable membrane, and the same galaxy that shapes it can also reach through and strike it. This is not hypothetical, because about 70,000 years ago, while human beings were already walking the Earth, a small dim star passed through its outer edge. We have found it and traced its path, and astronomers call it Schultz's star. It sailed through the outer Oort cloud while our ancestors looked up, never knowing a star had brushed against the shell of their home. Most of these passes are gentle, but there is one coming that will not be, and we already know its name. It is called Gliese 710, a dim orange star, a little more than half the mass of our Sun, drifting today in the constellation Serpens. Using the extraordinarily precise measurements of Europe's Gaia mission, astronomers have charted its course with near total certainty. In roughly 1 1/3 million years, Gliese 710 will not merely brush the outer edge of the Oort cloud. It will pass directly through it, deep inside the shell, and with the Gaia data that certainty is essentially 100%. And it is worse than a quick flyby, because Gliese 710 is slow. Most stars that wander past are tearing through, but this one ambles, so it will linger inside the cloud far longer than a faster star could. As it passes, it will briefly become the brightest, fastest moving object in the entire night sky. and in its wake, it will leave a disaster in slow motion. As it plows through the shell, its gravity will tear loose a swarm of comets and fling them inward toward the Sun, toward the planets. Astronomers who modeled the encounter estimate it will trigger a shower of roughly 10 naked-eye comets every single year. And this rain will not last a season or a century, it will last for 3 to 4 million years. I have to be honest with you about what that does and does not mean. A comet shower lasting 4 million years does not guarantee that one of them ever hits the Earth. The scientists who modeled this are careful to say the effect on our impact odds remains unclear, but it loads the dice, and then it rolls them over and over for longer than the human story has lasted. 66 million years ago, an object only a few miles across struck the Earth and erased 3/4 of all species alive, including the dinosaurs. A 4 million year reign does not promise a strike like that, but a long enough reign tends to find a target, a star none of us will ever meet, drifting through a structure none of us will ever visit, can reach across the ages and rain fire on the only home we have. And here is the cruel symmetry of it. The same shell that lets the galaxy reach in and strike us is the shell that keeps us from ever getting out. We are trapped on both sides of it, and the trap is not what is out there, it is the emptiness itself. Inside the planetary system, long-distance travel has a trick to it that science fiction calls island hopping. But once you cross the orbit of Neptune, the islands disappear. The Oort cloud holds trillions of objects, but they are scattered so thinly that the distance between any two rivals, the gap from Earth to Saturn, there is nowhere to stop and nowhere to refuel, just a void you must cross carrying every ounce of fuel from the moment you leave. With the propulsion we actually have, that crossing would take tens of thousands of years. A journey of 30,000 years is not a journey. It is a relay across 1,000 generations. So the Oort cloud seals our entire civilization inside the gravity of a single star more completely than any wall ever could. We can map the galaxy and dream about it, but our physical reach ends at the inner edge of a shell we cannot even see. And we have already sent a piece of ourselves ahead to measure that cage. Voyager 1 is the farthest object human hands have ever made, more than 15 billion miles out and still falling away from us. By every human measure, it is a triumph almost beyond words, and it is dying. Its nuclear heart is fading, its instruments are going dark one by one, and sometime in the next decade it will fall silent for good. It will not stop moving, but even at its speed, it will not reach the inner edge of the Oort cloud for 300 years. Long before it ever touches the true edge of the solar system, it will be a silent fossil drifting among the frozen worlds. Just one more object in the shell, carrying a golden record of our voices toward an audience of ice that will never listen. So what is the Oort cloud in the end? And it is two things at once that cannot be pulled apart. It is a cradle, the true territory of our star, holding the untouched material of our own creation, waiting in the dark for us to grow capable enough to read it. And it is a cage, the very scale that makes it magnificent, making it a prison. And it raises a question humanity has asked for a very long time. In a galaxy of 400 billion stars, so many of them older than our sun, why have we never heard from anyone? Maybe the answer has been hanging at the edge of every solar system all along. Maybe every civilization that ever arose found itself sealed inside its own shell of ice, close enough to dream of the stars and far too small to reach them. Maybe the silence we hear is not the silence of an empty universe. Maybe it is the silence of countless islands, each one walled off behind its own invisible barrier, calling out and hearing nothing come back. Somewhere in the constellation Serpens, a dim orange star is falling toward us right now, patient and certain, 1 million years away from an appointment it will keep. We have mapped the edge of our home, and we have never seen it. Thanks for watching, and I'll see you in the next one.